Hi, so today I'm going to talk to you about the future directions of mollusk aquaculture. So we're going to look at mollusk aquaculture, sea temperature rising, what will that mean for it? Can we use it to help water quality? And is it a sustainable farming method? And will we be able to farm other species than what we already do? So here are some mollusks. Mollusks are the largest marine phylum, comprising 23% of all the marine organisms. And cephalopod mollusks such as squid, cuttlefish, and octopus are amongst the most neurologically advanced of all the invertebrates. And then the gastropods are by far the most numerous, which account for about 80% of all mollusks. So aquaculture is the farming of fish, shellfish, crustaceans, aquatic plants, and other organisms. And it can be controversial and it triggers conflict across the world. The opposition is between those who favor an industry producing food for a growing global population and those who fear that such industrial production might have irreversible consequences on the marine ecosystem. And different factors will affect it in the future: climate change, regulations, marine spatial planning, public opinion, and consumer demand. So mainly in Scotland, it's Pacific oysters and blue mussels, but also razor clams, cockles, and native oysters. And bivalves are cultivated in their natural habitat, so there's no need to feed them. You'd be producing a very low carbon footprint eating farmed bivalves compared to farmed finfish. And this could increase public demand in the future from the more environmentally conscious consumer. And it's a relatively cheap type of aquaculture, again, because you're not feeding the animal directly. They're filter feeders and deposit feeders. And lastly, can be beneficial to the ecosystem, again, because they're filter feeders. So they filter the water around them, and this might be beneficial in some areas. So the three directions we're going to look at is climate change, mollusk aquaculture as a sustainable food source for the growing population, and researching into new species that we could be farming. This paper was done in Italy in the Adriatic Sea. So assessing the potential biomass yield is a key step in aquaculture site selection. This is challenging, especially for shellfish, as the growth rate depends on both trophic status and water temperature. And this study estimates that the potential for developing oyster farming in Western Adriatic Sea and industrial relevant indicators such as individual weight and days required to reach market size were mapped. And more uniform growth was seen up in the north here, in the North Adriatic coastal area, compared with the southern, where there was higher levels of chlorophyll and the summer temperatures exceeded the critical temperature limit for longer periods of time. So these results could be used for planning and identification of allocated zones for aquaculture, and it could also be used for looking at insights onto the changes of potential productivity indicators due to climate change. And then mussels and climate change. So there's conflicting opinions here as well. Some more research will be needed. So some are saying that effects will be minor, and others are saying that increased temperature will increase bioaccumulation of metals. And then there's more papers suggesting that it's going to affect, the rising sea temperature is going to affect the byssus threads of mussels, weakening them and changing their mechanics. And can we use it to help water quality? So oysters can filter up to about 96 litres of water a day, and then mussels about 40 litres of water a day. And there have been studies showing that focusing on picophytoplankton as a food source for filter feeders, and it suggests that this plankton makes up about 29% of the energy budget of commercial mussels. And this paper here demonstrates that the plankton carbon is effectively assimilated by mussel tissue. And because climate change is predicting that there's going to be an increase in plankton biomass globally, this could be beneficial to mussel aquaculture. And then eutrophication is another serious issue in aquatic ecosystems globally, but specifically has negative effects in the Baltic Sea area, where algal growth associated with excess nutrients has caused widespread dead zones. And then the farming and harvesting of native mussel species in these areas could counteract the eutrophication effects. And then over here we did oysters. So oysters were looked at for eutrophication as well, but there's not enough research on this yet. Then mollusk aquaculture, is it a more sustainable protein food source? So large-scale shellfish cultivation could contribute to remediation of the atmosphere, for the simple reason that about half the weight of shellfish harvest is the shell, and the shell is made up of made by removing carbon dioxide from the atmosphere and turning it into calcium carbonate. And then commercially grown bivalves are among the most sustainable food forms of human food. So shellfish cultivation is the only industry on the planet that could massively expand without damaging the environment. And then furthermore, it's estimated that mussel farming sequesters 3 times as much carbon as terrestrial ecosystems retain. And in general, non-fed invertebrates are more than likely better than fed invertebrates or vertebrates. And then of any aquatic animal species group that we eat, bivalves appear to be the most promising in terms of minimizing ecological harm, and in some cases can even be beneficial. So they're minimizing food security harm, minimizing animal welfare concerns related to captive rearing. And then another thing is bivalve aquaculture used to account for about half of the global aquaculture back in the 1980s, but now due to the explosion of finfish farming, it only accounts for about 30%. And this is the opposite direction we want to be going in. We want to be looking at foods that are more sustainable for the future for the growing population. And then in the future, will we be able to farm other mollusk species successfully? So like octopus, for example. So the development of octopus aquaculture has been driven by strong market demands in the Mediterranean, South America, and Asian countries. But the thing is, octopuses live short lives. They grow rapidly and mature early. And when they're mature, they're about 2 to 3 kgs, which is heavy for an invertebrate. But the bottleneck currently hindering the commercial development of octopus aquaculture is the difficulty in rearing octopus in their early paralarval stage. And paralarvae is the name of the larvae of cephalopods, and they're really small, less than 3 millimeters in size. So currently rearing techniques just aren't advanced enough, so there's high mortality. And then other issues with octopus aquaculture, like the feed needed for farmed cephalopods, could deplete the stocks of the prey for the wild version. And also they're really intelligent animals and cunning problem solvers. And then the economic benefit might be outweighed by the adverse ethical environmental consequences. To summarize, aquaculture is one of the fastest growing food production sectors in the world, and it's now responsible for about half the global seafood production. Bivalve aquaculture looks like it's going to be one of the most sustainable seafood sources. And then bivalve aquaculture also provides ecosystem services such as your nutrient removal and eutrophication or carbon sequestration. However, this production activity is highly dependent on the local environmental conditions and consequently sensitive to climate change. And those are the references. And if you have any questions, I'd be happy to answer them. So thank you.